Dear students, today we start exercise 5.4. 5.4 is very simple exercise. First of all, we will study some important terms, then we will solve exercise. The first term is order pair. What is order pair? Elements written in the form of bracket, small bracket, A, comma B is called order pair. If we write the elements of the two sets in this form, like small bracket A comma B, this is called order pair, where A is first element and B is the second element. In this order pair, A represent first element and this B represent second element. If we want to show this order pair on the graph, so we draw the first element on x-axis and B will draw on the y-axis. Remember that students, A B order pair is equal to order pair CD if only if A is equal to C and B is equal to D. Cartesian product of sets. Let us suppose we have A and B two non-empty sets. Then Cartesian product of A and B is denoted by A cross B and is defined as A cross B is equal to AB is order pair such that A belong to A, small a belong to A and small b belong to B. Now to explain Cartesian product, for example, let us suppose we have a set A which has element 1, 2, 3 and B set which has element small a and small b. Now we want to find the Cartesian product of these two sets. So let us suppose let set A has 3 elements and set B has 2 elements. To find out A cross B, the formula is m into n, in which m represent the element of set A and n represent the element of set B. So 3 2s are 6. So when we find the Cartesian product of A cross B, we have 6 order pair like this. A cross B, first we write set A, then cross, then set B. Now to find order pair, this element, first element 1 with A like this first element, then B, then second element 2 with A and B like this, then the third element 3 with first element of set B, A and B like this, and we will represent in this the order pair. Now another term is binary relation. What is binary relation? Let we have two sets A and B. A and B are two non-empty sets. Then a binary relation which is denoted by capital R from set A to B is a subset of A cross B. For example, a formula to find out binary relation, number of binary relation is equal to 2m into n, where m is the element of set A and n will represent the element of set B. For example, let us suppose we have a set A which has element 1, 2 and which we have set B which has element A, B, C. Then A cross B is equal to A with these 1 with these all elements and then 2 with these all elements like this. This is called A cross B Cartesian product. Now taking subset from this A cross B is called binary relation like this. Empty set, then R1, R2, this order pair writing in brackets, then R3 writing two pairs like this and this, then R4 writing again two pairs, these two pairs, then writing R5 writing three pairs. So writing subset of A cross B, this is called binary relation. Now domain of the binary relation. Domain of binary relation R from A to B is a set of all first element of the ordered pairs which belong to R and is denoted by DOM R. DOM R is the symbol for domain of a binary relation. Mathematically, it can be defined as domain of the binary relation is equal to a small a belong to capital A in set A such that A, B in bracket that is order pair belong to binary relation. Range of binary relation. Range of the binary relation from A to B is the set of the second element. It's the set of the second element of the order pair which belong to R and is denoted by ran R. Ran R is the symbol of range of the binary relation. Mathematically, it can be defined as range of the binary relation is equal to small b belong to set B such that small a b in bracket that is order pair belong to binary relation. For example, as we already studied binary relation R5, in this binary relation 1, 2, 3, the set of 1, 2, 3 is called domain and the set of A, B and C is called range like this. Domain of R5 1, 2, 3. 1, 2, S2 is repeated. Range of this binary relation is ABC. Let us suppose we have another binary relation R4. In this binary relation 2 is repeated, so we will write it one time, so the domain is 2 and the range is AB. Now moving exercise 5.4. Question number 1 is given. In this question, set A is 1, 2, 3 and set B is 4, 5. Then write 3 binary relation from A to B. Write 4 binary relation from B to A. 4, then write 4 binary relations on A. Write 2 binary relation on B. Solution. Data. First of all, set A which is 1, 2, 3. Then set B which is 4, 5. Part number first, 3 binary relation from A to B, that is R1, R2, R3, question mark. First of all, from A to B, so we will find A cross B. The first work is we will find A cross B, the Cartesian product of A and B. First we write set A, then cross, then set B. Then 1 with 4 and 5, then 2 with 4 and 5, and then 3 with 4 and 5, writing in the order pair. Now R1, let us suppose taking one order pair from this A cross B, so this is R1. Again R2, taking 2 pairs, let us suppose we take this pairs with this pair. Then R3, taking 3 pairs, let us suppose first pair, then 2 pi pair, and then 3 5 pairs. Now the other parts is write 4 binary relation from B to A. B to A means first of all we will find B cross A, then we write 4 binary relation. Write down 4 binary relation on A. A means first of all we will find A cross B, then we will take subset from A cross B. Write down 2 binary relation on B. On B means we first of all we will find B cross B, the Cartesian product of B with B, then we will write 2 binary relation. Now question number 2, if set A is 1, 2, 3, 4, set B is 1, 3, 5 and the binary relation is given, xy is order pair such that y is less than x is a binary relation from A to B. Then write it in tabular form. Solution, set A is given which is 1, 2, 3, 4, set B is given which is 1, 3, 5 and the binary relation is given which is xy is order pair such that y is less than x. Now first of all we will find the Cartesian product of these two sets. The product A cross B is, first we write set A, then cross, then set B. Then writing the order pair, the first element with the second element and third element of the set B like this. Then second element with all element, then third element with all element of set B, then 4 with all element, like this. Now condition. Condition is given in the binary relation कि y is less than x. Remember the students, the first element represent x and the second element represent y. The first element is x and the second element is y. Now is given that y is less than x. So in this order pair, y is less and x is greater. In this order pair, y is less and x is greater. In this order pair, y is less and x is greater. In this order pair, y is less and x is greater. So the answer is 2 1, 3 1, 4 1 and 4 3. And now if you want to find the domain and range of this binary relation, so the domain is 2 3 4 and the range is 1 and 3. Question number 3, this is one of the most important question. Domain of the binary relation are xy is order pair such that y is equal to 2x is the set of 0 4 8. Find the range of the binary relation. Solution. Binary relation is given xy is order pair such that y is equal to 2x. Domain is given which is 0 4 8. And range, we will find the range. Condition. Y is equal to 2x. Remember that students, x is independent and y is dependent variable. And domain represent the value of x. Now y is equal to 2x. X is given 0. So putting in this equation, y is equal to 2 into 0, 2 zeros are 0, 0. X is equal to 4, then y is equal to 2 into 4. 2 4s are 8. X is equal to 8, then y is equal to 2 8s are 16. Now making tables, is x is 0, y is 0. X is 4, y is 8. X is 8, y is 16, like this. Now making binary relation from this. So the order pair are 0 0, 4 8, 8 and 16. Now writing domain and range is the first element 0 1 0 4 8 is called domain and 0 8 and 16 is called range. The first element is called domain and the second element is called range. Question number 4, this is again one of the most important question. Domain of the binary relation R is equal to xy is order pair such that y plus 1 is equal to 2x square is the set of the natural number. Now the domain is natural number. Find its range. Solution. Binary relation is given which is xy is order pair such that y plus 1 is equal to 2x square. Domain is natural number and natural number are those numbers which start from 1 up to so on. 1, 2, 3 up to so on is called natural number. And we will find the range. Condition is given y plus 1 is equal to 2x square. Y is equal to 2x square minus 1. This one will be shaped to the right hand side and this is called equation A. Now x and y. X, the value of x are already given which is 1, 2, 3, 4. So when the value of x is 1, then the y, putting in this equation A, 1 square 2 minus 1. 1 square 1 ones are 1, then 2, 1 multiply with 2, 2 ones are 2, 2. Minus 1 is equal to 1. Then 2 2s are 4, 4 2s are 8. 8 minus 1 which is equal to 7. 3 3s are 9 and 9 2s are 18. 18 minus 1 which is equal to 17. Then putting the value 4, 4 4s are 16 and 16 2s are 32 and 32 minus 1 which is equal to 31. Is the natural number up to so on, so this equation also up to so on. Now making tables x and y. When the x is 1, the y is 1 like this. When the x is 2, the y is 7 like this. When the x is 3, the y is 17. When the x is 4, the y is 31, up to so on. Now binary relation 1 1, 2 7, 3 17, 4 31 and up to so on. The first element is called domain, which is 1, 2, 3 and 4, and the second element which is called range, which is 1, 7, 17 and 31, like this.